Mission Control at the Johns Hopkins Applied Physics Laboratory, APL, in Laurel, Maryland, announced the successful impact at 7:14 p.m. EDT. As a part of NASA's overall planetary defense strategy, DART's impact with the asteroid Dimorphos demonstrates a viable mitigation technique for protecting the planet from an Earth-bound asteroid or comet, if one were discovered. At its core, DART represents an unprecedented success for planetary defense, but it is also a mission of unity with a real benefit for all humanity, said NASA Administrator Bill Nelson. As NASA studies the cosmos and our home planet, we're also working to protect that home, and this international collaboration turned science fiction into science fact, demonstrating one way to protect Earth. DART targeted the asteroid moonlet Dimorphos, a small body just 530 feet, 160 meters in. It orbits a larger, 560-foot, 780-meter, asteroid called Didymos. Neither asteroid poses a threat to Earth. The mission's one-way trip confirmed NASA can successfully navigate a spacecraft to intentionally collide with an asteroid to deflect it, a technique known as kinetic impact. The investigation team will now observe Dimorphos using ground-based telescopes to confirm that DART's impact altered the asteroid's orbit around Didymos. Planetary defense is a globally unifying effort that affects everyone living on Earth, said Thomas Zurbuchen, Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. Now we know we can aim a spacecraft with the precision needed to impact even a small body in space. Just a small change in its speed is all we need to make a significant difference in the path an asteroid travels. The spacecraft's sole instrument, the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, DRACO, together with a sophisticated guidance, navigation and control system T. These systems guided the 260-pound, 570-kilogram, box-shaped spacecraft through the final 56,000 miles, 90,000 kilometers, of space into Dimorphos, intentionally crashing into it at roughly 14,000 miles, 530 kilometers per hour to slightly slow the asteroid's orbital speed. DRACO's final images, obtained by the spacecraft seconds before impact, revealed the surface of Dimorphos in close-up detail. 15 days before impact, DART's CubeSat companion light Italian CubeSat for imaging of asteroids, Lycia Cube, provided by the Italian Space Agency, deployed from the spacecraft to capture images of DART's impact and of the asteroid's resulting cloud of ejected matter. In tandem with the images returned by DRACO, Lycia Cube's images are intended to provide a view of the collision's effects to help researchers better characterize the effectiveness of kinetic impact in deflecting an asteroid. DART's success provides a significant addition to the essential toolbox we must have to protect Earth from a devastating impact by an asteroid, said Lindley Johnson, NASA's planetary defense officer. This demonstrates we are no longer powerless to prevent this type of natural disaster. Coupled with enhanced capabilities to accelerate finding the remaining hazardous asteroid population by our next planetary defense mission, the Near-Earth Object, NEO, Surveyor, a DART successor could provide what we need to save the day. With the asteroid pair within 7 million miles, 11 million km. Over the coming weeks, they will characterize the ejecta produced and precisely measure Dimorphos' orbital change to determine how effectively DART deflected the asteroid. The results will help validate and improve scientific computer models critical to predicting the effectiveness of this technique as a reliable method for asteroid deflection. Beyond the truly exciting success of the technology demonstration, capabilities based on DART could one day be used to change the course of an asteroid to protect our planet and preserve life on Earth as we know it. Roughly 4 years from now, the European Space Agency's Hera project will conduct. To see the final images before DART's impact, visit go.nasa.gov. 3R1NW. For more information about DART, visit www.nasa.gov. DART. NASA. NASA's DART mission hits asteroid in first-ever planetary defense test. Science Daily, the 27th of September 2022. ift.tt/qfjzrwv. NASA. 2022, September 27. NASA's DART mission hits asteroid in first-ever planetary defense test. Science Daily. Retrieved September 27, 2022 from ift.tt/qfjzrwv. NASA. NASA's DART mission hits asteroid in first-ever planetary defense test. Science Daily. ift.tt/qfjzrwv. Accessed September 27, 2022. Thanks for watching. Please subscribe my channel for more videos.